study the electronic configuration of different elements. First we will study what is meant by electronic configuration. Electronic configuration means arrangement of electrons in each and every orbits. Now we are going to study electronic configuration of different elements in different groups as well as different periods. First I am showing you the periodic table. In that a rough idea as well as a quick revision I will show you. Yes, this is the modern periodic table. Here we are going to study the electronic configuration of most important groups as well as most important periods. Now here I am showing you, this is the first group of elements, that is containing hydrogen, lithium, sodium, potassium, rubidium, cesium, francium. But we need to study up to potassium. After that, second group of elements, that is containing beryllium, magnesium, calcium, strontium, barium, radium. But out of them, we need to study up to calcium. Then we are coming to here. This is the seventh group, or we can say that halogens. They are fluorine, chlorine, bromine, iodine, astatine as well as 10SN. But these all things are not necessary for you. You have to study up till here bromine, maximum bromine you have to study. Then after that we are going to study about zero group elements. Zero group elements are helium, neon, argon, krypton, xenon, radon and oganesson. But you need to study up to argon. Now we are going to study about even periods. There we are going to show importance of only these two periods. That is lithium, second period it is. Then this is the third period. Second period containing lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon. Then third period containing sodium, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine as well as argon. These periods as well as which all groups I said, those groups detailed study we are going to do. Only we are going to study their electronic configuration as well as we have to compare them. Let us see now. Now, first I am going to write the names of the elements. Now we will compare the electronic configuration of elements which are there in the different groups. Now first here, this is the first group elements, lithium, sodium, potassium. This is the second group elements, beryllium, magnesium, calcium. This is the seventh group or halogens. They are fluorine, chlorine, bromine. This is the zero group elements or noble gases. They are neon, argon, krypton. Now let us see their electronic configuration. Now here lithium, its atomic number is 3. So electronic configuration I am writing as 2, 1. That means first orbit has 2 electrons, second orbit has 1 electron. Now sodium, its electronic configuration 2, 8, 1. First orbit has 2 electrons, second orbit has 8 electrons, third orbit has 1 electron. Now potassium, its electronic configuration 2, 8, 8, 1. So you see here, first orbit has 2 electrons, second orbit has 8 electrons, third orbit has 8 electrons, fourth orbit has 1 electron. When you compare the electronic configuration of these three elements, outermost orbit has 1 electron, 1 electron, 1 electron. So the speciality of group 1 elements are in their outermost orbit has 1 electron. Now you see, we are coming to second group, that is beryllium. Its atomic number is 4, so electronic configuration is 2, 2. Magnesium electronic configuration 2, 8, 2. Now calcium electronic configuration 2, 8, 8, 2. When you add these electrons number, you will get the atomic number. Here these all are the electrons number. First orbit has 2 electrons, second orbit has 8 electrons, third orbit has 2 electrons. When you total them, you will get this atomic number. Similarly here also. Now we are coming to halogens. Electronic configuration of fluorine 2, 7. Here chlorine 2, 8, 7. Here bromine 2, 8, 18, 7. Now here when you compare, you can see that outermost orbit has 7 electrons. You can see everywhere. In each and every element has 7 electrons in the outermost orbit. So this is the speciality of 7th group. Second group, when you see, outermost orbit has 2 electrons. First group you see here, everywhere you can see 1 electron in the outermost orbit. Now we are coming to the 0 group or noble gases. Now its electronic configuration again I am writing, that is 2, 8 argon 2, 8, 8. Now krypton when we see 2, 8, 18, 8. When you see the outermost orbit, all are having 8 electrons. Now I given only 3 elements here. Each and every group 3 elements only I shown you. This is only required to you. More than that not necessary. Now one more thing I am saying you here. When you see the first group elements, first element I written, that is lithium. It has only 2 orbits. But next will come 3 orbits. Next will come 4 orbits. Here if you are taking beryllium, it has only 2 orbits. Magnesium has 3 orbits. Calcium has 4 orbits. Fluorine 2 orbits. Chlorine 3 orbits. Bromine 4 orbits. Neon 2 orbits. Argon 3 orbits. Krypton 4 orbits. Now I am making diagrammatic representation of electronic configuration of these elements. Few I will show. I won't show every elements I am not going to show. Only few. Then also you will get the idea. Okay. First I am showing you lithium. Its electronic configuration I am drawing now. Its atomic number is 3. That means the protons number also 3. Protons are positively charged particles which are present in the nucleus of an atom. Now, in the first orbit, we can say that here first orbit has 2 electrons. So I am making here 2 electrons. Then second orbit has only 1 electron. So this is the diagrammatic representation of the electronic configuration of lithium. Now I am showing you sodium. Sodium, its nucleus, its atomic number is 11. That means protons number again 11. They are positively charged particles. Now around it, first orbit has 2 electrons. Second orbit has 8 electrons. Third orbit has 1 electron. Now we are studying about potassium. This is its nucleus. Atomic number is 19. That means the protons number, that is also 19. Protons have positive charges. Now this is the first orbit. It has 2 electrons. Second orbit has 8 electrons. Then the third orbit has only 1 electron. Similarly, here you see 2, 1. So 2. First orbit can occupy maximum 2 only. Then that 2 I made. After that the next orbit begun, that is having 1 electron. Then here first orbit completed with 2 electrons. Second orbit can occupy maximum 8. That is completed here. Then the new orbit begun. That is having 1 electron. Now here this is about potassium. First orbit can have maximum 2. Second orbit has maximum 8. Here again third orbit is there. Only I made 1. Here how many are there? 8 electrons are there. 2, 3, 4, 5, 6, 7, 8. Then it is having 1 more orbit. That means potassium has 4 orbits are there. Then the last orbit has 1 electron. So here you see, here in the case of lithium it has only 2 orbits that I drawn here. Sodium has 3 orbits, 1, 2, 3. Then potassium has 4 orbits, 1, 2, 3, 4 orbits. Now similarly these elements, they are also electronic configuration, you can make it. First orbit has 2 electrons, second has 2 electrons. Then here magnesium has 2 electrons in the first orbit, 8 electrons in the second orbit, third orbit has 2 electrons. Then calcium has 2 electrons in the first orbit, second has 8, third has 8, fourth has 2. Like that way, now same way you can be able to draw electronic configuration of all these elements. Here all elements electronic configuration I written. Now one more example I will show you, that is here argon. You see here its nucleus has how many protons? See, atomic number of argon is 18. So we can write here 18. Now protons are having positive charge. So P is equal to 18. All are positively charged particles. After that first orbit has 2 electrons. So I am making here first orbit with 2 electrons. After that second orbit has 8 electrons. 3, 4, 5, 6, 7, 8. Now again third orbit has 8 electrons. So we have to make 8 electrons here. So this is the electronic configuration of argon. Okay. Similarly all you can be able to make it. Now we are going to compare the electronic configuration of second period as well as third period. Now we will compare the electronic configuration of second period elements as well as third period elements. Now here this is the second period elements. Lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon. Third period elements. Sodium, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine, argon. Now here atomic numbers also I written here. Lithium atomic number 3, beryllium 4, boron 5, carbon 6, nitrogen 7, oxygen 8, fluorine 9, neon 10. Now here sodium 11, magnesium 12, aluminium 13, silicon 14, phosphorus 15, sulfur 16, chlorine 17, argon 18. Now let us write their electronic configuration. Lithium 2, 1, beryllium 2, 2, boron 2, 3. That means its total should be equal to its atomic number. Here 2, 4, here 2, 5. First orbit can occupy maximum 2 electrons. Second orbit can occupy maximum 8. Let us see now. Here in case of oxygen, electronic configuration 2, 6. When we add these two, it should be equal to atomic number, that is 8. Now fluorine atomic number 9, then electronic configuration 2, 7. Neon electronic configuration 2, 8. 2 plus 8, 10. So that is equal to the atomic number of neon. Now let us study here sodium. This is the third period elements. Electronic configuration 2, 8, 1. Magnesium electronic configuration 2, 8, 2. Here aluminium electronic configuration 2, 8, 3. Now silicon electronic configuration 2, 8, 4. Its sum should be equal to the atomic number. Here now 2, 8, 5. Sulfur 2, 8, 6. Now electronic configuration of chlorine 2, 8, 7. Argon 2, 8, 8. Now when we compare the electronic configuration of all these elements which are in the second period, we will see one common feature here. What is that? All are having 2 orbits only. Everywhere you can see each one, you can find that having only 2 orbits. When we compare electronic configuration of third period elements, you will find that they have 3 orbits. That is the speciality of elements present in one period. Which period they belong to, that much number of orbits they will have. Now their few elements electronic configuration I am drawing and showing you. Lithium again, nucleus has 3 protons. How I got 3 here? It's seeing its atomic number, I got the number of protons. Why? Because protons number as well as atomic number equal. Even we can say that electrons number as well as atomic number same. So once again, protons number, electrons number and atomic number of an element is same. Now here protons are having positive charge. Now we see first orbit has 2 electrons. First orbit can occupy maximum 8. Then second orbit, you people already studied the electronic configuration, capacity of each and every orbits in the last year. So first orbit can occupy maximum 2, second orbit can occupy 8, third orbit can occupy maximum 18, fourth orbit can occupy maximum 32, fifth orbit can occupy 50. So for finding that, you people already studied one formula also. That formula is 2n square. You people studied one 2n square. This formula if you will use, you will understand 7th orbit has how many electrons can occupy. Maximum electrons how much can occupy. That all we can find out by using the formula 2n square. Then even you people studied that first shell or first orbit known as K shell or K orbit. Second shell or second orbit known as L, third one M, fourth one N, fifth one O, sixth one P. K, L, M, N, O, P. Then the last one Q. Why total how many orbits can be? Only 7 orbits. Why? Because only 7 periods having elements. 8th period is not there. Total 7 periods only. So here I mentioned 7 periods, but all these periods or all these orbits, how many elements are coming? That much idea is required. That is also no need of by hearting. You can find out by using this formula. For example, one that K already you people studied, that is the first orbit, 2 electrons can be. Second one, that is L orbit, that can occupy maximum 8. Third can occupy. So first I am writing first shell or first orbit can occupy maximum 2. Second orbit can occupy maximum 8. Third can occupy maximum 18. Fourth orbit can occupy maximum 32. Fifth can occupy maximum 50. Okay. So we will just clarify that whether it is coming true or not. So I am doing now. This is the fifth orbit, whether it is correct or what. So here 2 into. Then fifth orbit has. Even I have doubt whether it is correct or what. So let us test that. For that 2 into. N means a number of orbit. Which orbit we are finding? Fifth orbit has, or fifth orbit can occupy maximum how many electrons? So what I am doing? 5 square. N means orbit's number. That is 5 then square. 5 into 5, 25. 25 into 2, 50. So this is correct. Now sixth orbit can occupy how many? Seventh orbit can occupy maximum how many electrons? Let us see that. Sixth orbit. That is 2 into 6 square. 6 square means 6 into 6, 36. 36 into 2, that is 72. So sixth orbit can occupy maximum 72 electrons. Then the last, that is seventh orbit, can have maximum how many? Let us find out now. That is 2 into 7 square. 7 sevens are 49 into 2. Answer will be 98. So the seventh orbit can occupy maximum 98 electrons. More than that, there is no orbits. Why? Because 7 periods containing elements. 7 periods means there will be maximum 7 orbits. Now, when we draw the electrons, this many 98, 18, 72, 50, all these electrons drawing is very difficult, but it is not necessary to you. So I am not drawing such a bigger elements means electronic configuration I am not drawing. Okay. Plus even for writing also it is not necessary to you. So which all elements I written, that much is enough for you. More than that, no need of by hearting. Okay. Now you see. So here lithium I written, I drawn the electronic configuration of lithium. That is first orbit has 2 electrons, second has only 1 electron, 2, 1. Similarly now beryllium, its nucleus has here atomic number 4. So nucleus has 4 protons. Protons carry positive charge, electrons carry negative charge, neutrons have no charge. They are neutral. This thing also you people studied in the previous class. Now you see first orbit has 2 electrons. Second orbit has again 2 electrons. Same to same I made. Now third, fourth, seeing that first orbit has 2 electrons. Second orbit will have 3 electrons. Then 4, 5 like that. Then here this is neon. Its first orbit has, first I am making the nucleus, protons number 10, they carry positive charge. First orbit has 2 electrons, second orbit has 8 electrons. Similarly, you can make the electronic configuration of these elements also. I think you are clear with the electronic configuration of all the elements which are in the group as well as which are in the period. Now, one more thing I am saying you, in the group, when we go from top to bottom, the orbits number will increase. At the same time, their outermost orbit will have same number of electrons. When we study about the period, their last orbit will have different number of electrons. Here you see, last orbit has 1, here 2, here 3, here 4, like that. At the same time, their orbit number will be same. Here 2 orbit, 2 orbit, 2 orbit, 2 orbit, like that. Here, this is the third row or third period elements. When you compare their electronic configuration, you can find that each and every element has 3 orbits. Everywhere 3 orbits you can see, and last orbit has different number of electrons. See, here 1, here 2, here 3, here 4, like that. But number of orbits will be same. So that is the speciality of period. Thank you.